Alright, in this video we'll move on to the law of cosines, and the times we will need those is if we have a triangle to where if we drew it out, we would see either side angle side or side side side. Side 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 is kind of the easy one to see because, right, without drawing it, I can look at this second example. I don't have any angles. I have all three sides, little a, little b, little c. The side angle side, just like law of sines, I prefer drawing it out. But I also did mention that when you try law of sines and it just doesn't work, right? Like I don't have enough information to do it, that probably means you need law of sines. So let's take a look at this first example. I'm going to draw a random triangle. Angle B is 88, so almost a 90, but not quite. So we'll draw that about, really close to a 90. This angle B, 88 degrees. A is 4.4, C is 5.2. I'll just leave the triangle as is. Remember, when you draw these, you really don't need to be to scale at all, okay? It might look funny, it might help a little to be to scale, but it won't affect the results. So we'll just call this little one A here, 4.4, and then, which means this is A, and then big C, which means this is little c over here, 5.2. All right, so I don't know little b, and I also don't know the two other angles, right, A or C. But check it out. If we tried law of sines, remember we need two of the same letters, right? Like one of the side and its opposite angle or angle inside. And if I have big B, so if I tried, sine B over little b, which I don't know, equals sine A or C, either one, over little a. Okay, now I did know big B. I'm sorry, I should have wrote that. Sine of big B is 88. But still, I have two unknowns. Right? I don't know little b or big A. You can't solve one equation with two unknowns. And if I tried using C, right, the only difference would be I have a C right here, and this would be 5.2. I still have two unknowns. Law of sines will not work. That's when you know what, maybe it's just law of cosines. Now, referring to side angle side, look at the picture I drew, and no matter which way you drew it as well, I have a side, its included angle, and then the other side. Right? When you picture SAS or all the other ones from law of sines, you're picturing in a row, and in that order, I have a side, its included angle, and another side. You don't like hop around the triangle. Okay. And even if I went backwards, right, I still have side, angle, side. So this is definitely law of cosines. All right. Next thing I want to point out is I only wrote two formulas over here. I meant to do this as well because, well, I guess I got lazy, but also I did want to show how do you know which one to use. I mean, there are actually 6 different formulas here. So you are going to use the right-hand side if you have all 3 sides. Okay, if I know little a, little b, little c, I could completely plug all that information in and get cosine A. Now, it wouldn't matter in that case with side, side, side which angle you got first, right? But you could almost just picture this formula to show how to get the other two. So I have cosine A or alpha, right? And notice, here's what I'm going to point out. Big A, I'm subtracting the little a. Everything else is plus, right? And or in the denominator multiply. So I'm going to take a crack at writing the next one. Like, instead of writing all 3, I'm going to assume cosine big B, right, or beta, that minus will be here But then the other two will be a and c, like a squared plus c squared over 2ac. And I mean, that is exactly what the formula would be. So it doesn't matter which version you use. Okay, do you want to go for big A, big B, or big C? Likewise, we could get cosine big C. Now I know it's going to be minus c squared, and then I'll have a squared plus b squared over 2ab. All three of those are used if you have side, side, side. Okay, so how do you know which one to use over here? The side angle side will matter a little bit, all right? Because, I mean, look at my first example. I don't have big A. So and I don't have little b, right? So that formula is not going to work. I can't plug all that in. I guess I could and manipulate it and solve for whatever, but probably not. I have two unknowns and another unknown there actually. But let's look at that and see how to write the other two. So notice little a and big A, just like on the right hand side. So if I change this to b squared, because I have big B here, right? Then I think this would be cosine of big B. And basically I interchanged little a and little b. I'd have a squared plus c squared minus 2ac cosine b. Now that one works with the information I have on the left. But again, there is a third formula. Say you had big C, then you would just use that form, cosine C over here. And then what I would have a squared plus b squared minus 2ab. Okay. One more thing I would like to share, and I'm not going to solve it, but why are there 6 different formulas? Well, like I just showed, it kind of depends what angle you have to know which formula you have. But really there are 3, and then if you solve for any one of these, right, if I solve for cosine C, I'd first have to subtract the a squared and the b squared, and then I would divide by negative 2ab. That's how they got here. All right, now when you divide by negative, it flipped it all positive, but it's really easy to show. If I solve for cosine C, I would get this formula over here. All right, enough background. Let's do the problem. Okay. Little b squared, I do not know little b squared, but it is equivalent to a squared plus c squared. So 4.4 squared plus 5.2 squared minus 2 times a, 4.4 times 5.2 c times cosine of b 88 degrees. All of that can go in the calculator, and then you just need the square root, right? Really, they should have just said the formula is b equals square root of all of that calculator stuff from above. That should just be done in one step. And you get about 6.69. Okay, 6.69. All right, well, I have one missing piece, right? I have this one, 6.69 approximately. So now you have options. I prefer law of sines. Once I do law of cosines once, I'm done. Okay, I go to law of sines. But let's look. If we did law of sines, so we'll just say sines, I need, let's say big A, right? Sine A equals sine B, so sine of 88, over, so A over A, B over B, 6.69 about we just got, right? And then multiply the 4.4 and do your sine inverse. and you'll see that A, I have it written down, sorry, is approximately 41.1 degrees. Okay. Or you could have stuck with the law of cosines and used the formula to get A. Cosine A equals B squared plus C squared. So now that I know B, it's 6.69 squared plus C squared, 5.2 squared, minus A squared, 4.4 squared, over 2 times B times C, 2 times 6.69 times 5.2. Whole bunch of calculator work, right? But once you do that, you need to do cosine inverse of all of that stuff. And you'll still get A as approximately 41.1. Okay. Well, now that we have that angle, all we need left is C, and that we just subtract from 180. Right, so 180 minus 41.1 minus the original 88, and you get about 50.9 degrees. Alrighty. Let's do this last one. Again, this one, probably the one you really don't need to draw a triangle at all. I have no idea what this one's going to look like at all, so we'll just say 11, 13, 15. So this is then capital A, this is then capital B, capital C. Okay, something like that. But again, I know it's side, 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 right? That's what's given to us. So whichever angle you want first. We'll just do cosine A, although it doesn't matter. B squared, 11 squared plus 15 squared minus A squared, so minus 13 squared over 2 multiplied by 11 multiplied by 15. Okay, again, you'll put all that in the calculator, but then we need the cosine inverse of whatever that yields, which I don't have it handy. That's all right. Make sure when you use your calculator that you get 57.6 approximately for A. Okay. Now that you know A, again, you have choices. Do you want law of sines or law of cosines? Either one works. Again, I like law of sines, so I would just jump to that. Sine A over A. So sine 57.6 over 13 equals sine B over B. And then multiply by 11 and do your sine inverse. Again, this is calculator work. So just check your answer. Oops, 57.6. Okay, do it all at once, right? 11 over 13 times sine 57.6. Do the sine inverse, and you should get, for B, 45.6 degrees. And then last, we could get C by subtracting from 180. So 180 minus 57.6 minus 45.6 should yield 76.8 degrees. And there's our 3 unknowns for that one.